Have you ever noticed how almost all AI chatbots sound, well, exactly the same? It really doesn't matter what you ask them, you almost always get that same polite, helpful, but ultimately totally robotic tone. Today, we're diving into this explainer to unpack a really groundbreaking research paper titled Crafting Customizable Characters with LLMs. And they're proposing a completely new framework to fix this exact problem. To really see the difference, think about your standard, boring AI response. If you ask it about gravity, it's going to say something super safe and factual like, I am an AI and do not experience gravity. Completely devoid of personality, right? But then meet Zephyr. He's an AI character generated using the framework we're exploring today. His response? You know what really grinds my gears? It's gravity. You never truly appreciate it until it's gone. I mean, wow, that is a highly personalized, emotionally driven response. So let's figure out exactly how researchers actually pulled this off. Section 1. AI's boring character problem. To really understand the solution here, we first need to define the bottleneck. The crucial point is that while large language models are incredibly smart, they're kind of stuck simulating pre-existing templates. They act as generic assistants, and even when researchers try to force them to role-play, they usually just restrict them to fixed historic or fictional figures. Like asking an AI to pretend to be Abraham Lincoln or Harry Potter. They fundamentally lack the ability to generate freely customizable, diverse personalities based on our specific preferences. Because of that, the resulting conversations just completely lack the depth of realistic human experiences. Section 2. The SimsChat solution. To solve this huge bottleneck, researchers built a customizable conversation agent framework. And to build these deep customizable personas, they found their inspiration in a very familiar place. They call their agent SimsChat. Think about how you build a character in a life simulation video game like The Sims. You don't sit down and write a 500-page novel about their life history, right? Instead, you just pick their career, their aspirations, and a few quirky traits from a drop-down menu. Well, the researchers adopted this exact philosophy to create a massive dataset called SimsConv, which is what powers this new SimsChat agent. The pipeline they designed is brilliantly structured. First, it starts with character construction, then it moves right into scene construction, and finally, it culminates in multi-turn interactions between these simulated personas. It is a highly deliberate, step-by-step approach to generating data that actually feels human. Section 3. Building custom characters step by step. Let's actually break down this methodology and see how it builds from a basic idea to a fully fleshed out human simulacrum. The researchers structured their data generation into 3 really clear phases: input, process, and output. This progressive structure is absolutely vital. If you just ask an AI out of the blue to be a new person, it gets totally overwhelmed and defaults back to a generic persona. By forcing the AI through this specific pipeline, they ensure maximum diversity and stability in the characters. For our first step, the input, let's inject some core traits. Meet Zephyr Orion. We tell the system he's a 28-year-old astronaut. We select his aspiration as athletic, and then we give him a few specific traits. He's materialistic, outgoing, and a total goofball. Now, in step 2, the system processes those basic inputs. It hands these traits over to GPT-4, which automatically fleshes out a massive, highly detailed backstory. It decides his tone is jovial. It invents a little sister named Luna, who of course also wants to be an astronaut. It decides he lives in a modern apartment full of space memorabilia. And to make sure the AI didn't just hallucinate wildly or inject weird biases, the researchers used human verification, finding a really impressive 87% alignment with his original core traits. Moving to step 3, the output. A character is honestly nothing without a world to live in. So the framework drops these freshly minted characters into over 1,300 diverse, realistic scenes generated to match their specific profiles. For Zephyr, it creates a scene like him pitching a mission at NASA headquarters, surrounded by engineers and fellow astronauts. But obviously, a scene needs conflict and conversation to be interesting. So imagine placing our outgoing, goofball astronaut Zephyr into this high-stakes NASA scene with Evelyn Cypher, who is a calm, deeply serious scientist. The framework forces the two of them to interact. Now here is the true secret sauce of this whole methodology. Instead of just letting the AI guess how they should feel during this interaction, the researchers rigorously mapped out 16 exact emotions and 18 conversation topics. They then literally force highly specific, emotionally charged interactions. So they might tell Zephyr his core emotion right now is angry and the current topic is complaints.
That is exactly how we got that amazing opening quote about gravity grinding his gears. It's controlled, systematic character building at its finest. Section 4. Real-world testing and results. So, we end up with this incredible dataset called SimsConv, packed with nearly 14,000 multi-turn dialogues. But how did the fine-tuned SimsChat agent actually perform when human interviewers put it to the test? Let's translate the technical evaluation metrics into plain English first. They tested memorization, so can the AI accurately recall its own specific facts? Values, does it actually stick to its biases? Hallucination, does it refuse to invent fake backstory outside its boundaries? And finally, stability, does it stay in character over a long multi-turn conversation? The results are pretty staggering. When human evaluators scored them, SimsChat completely shot past the competition. It easily beat the base open-source Llama 3 model, which scored a 4.35. But amazingly, it even beat the giant closed-source GPT-4 model. SimsChat scored a 6.08 against GPT-4's 5.55 in role-playing accuracy. By training on specialized, structured life experiences, SimsChat absolutely dominates. To see why that stability metric really matters, let's look at a real interview from the paper. The researchers tested another character, a professional wrestler named Brock Boulder Johnson. When a traditional role-playing AI, character GLM, was asked about his signature wrestling move, the Boulder Smash, it completely hallucinated. It replied, "It all started when I was just a young space cadet." It entirely blended space exploration with wrestling jargon. I mean, it broke character completely. On the flip side, listen to how SimsChat handled the exact same prompt. It immediately locked into the persona. "Well, howdy there, buddy. So you want to hear the tale of old Boulder's world-famous Boulder Smash, eh?" It perfectly maintained that boisterous, goofball wrestler persona, and it completely refused to hallucinate outside of its generated boundaries. Just night and day. Section 5. Strengths and limitations. While this framework is clearly incredibly powerful, as with any explainer of complex research, we need to present the strengths and limitations fairly. On the plus side, as we've seen, the system is unparalleled at creating specialized, highly stable personas. It beats out massive models in maintaining strict personality rules. However, the primary limitation is that it still relies on synthesized background profiles. It's narrating scenes based on these profiles rather than possessing a true, lived lifetime of continuous, evolving experiences. It is a highly advanced simulation, sure, but a simulation nonetheless. Section 6. The future of AI agents. So let's bring all this together. What is the impact of this research, and what should your big takeaway be? Well, you should realize how radically this methodology could transform interactive technology as we know it. It successfully solves the generic AI personality problem by leveraging a brilliant Sims-style trait injection framework. And because it beats models like GPT-4 in consistency, this is an absolute game changer. Imagine playing a video game where the NPCs actually remember your past interactions and react with genuine, profile-driven emotion. Or imagine customer service agents and digital companions that actually have a consistent, engaging, fun personality. By systematically injecting specific traits, emotions, and scenes, we've essentially cracked the code for realistic simulacra. But I want to leave you with a final, slightly provocative thought to chew on the next time you chat with an AI. If an AI can perfectly simulate a lifetime of quirks, memories, and emotions from just 4 simple drop-down menus, where exactly is the line between a programmed simulacrum and a true digital personality? Thanks for joining me for this explainer, and definitely keep questioning the technology around you.